All right, I've got 10:02 in the great state of New York. So my obligatory 2-minute wait period is up. We're going to go ahead and roll into this. My name is Tim Ashmore. I work for CDM Smith. I'm what we call a client service leader, but that really just means that I run a book of business. I'm primarily focused around utilities and decarbonization efforts, particularly related to thermal energy networks. So I'm very excited to be here with everybody today. This is a panel that I was very hopeful we could get together, and I'm thrilled that we have everybody that we do. So we've got a chance to hear from a handful of utilities who are at a couple of different phases in their UTEN development project lifecycle, let's say. The utility entrance into the geothermal market and thermal energy networks on the whole has been certainly very exciting for industry. And I think understanding the project development process and what it takes to establish a program around developing thermal energy networks is valuable for all of us to hear, regardless of where we live in the value chain. So to start out, we're going to go ahead and just hear a little bit about what everybody's working on. Before we do that, I'll just read a couple of introductions for everybody, and then we'll just get right into sort of what I'm hoping is a lively discussion across the panel about a number of topics ranging from the actual project development activities through working through the regulatory process, the design process, test drilling, and the like. So all of us right now are in pre-construction phases, right? We're not to construction, so I think that the topics will stop short from getting into that. But there's a lot to be gleaned from just the activities that we've gone through so far, getting to basically, the final stages of design. So first, I've got Greg Koumoullos to my left. Greg's the department manager at Edison, and he's leading the utility thermal energy networks team, which I think has probably between 5 and 10 people on it, a number of consultants. And they've got 3 large thermal energy network projects proposed in their service territory, which is Metro New York, downtown New York City, Westchester. So arguably one of the most difficult to build and design in areas in the country. Next, we've got Bess Gorman. Bess is Assistant General Counsel and Director of the Future of Heat and National Grid. She's Regulatory Counsel for 3 thermal energy networks located in Brooklyn, Troy, and Syracuse. They're all being designed for National Grid for supporting the PSC order. She's also served as regulatory counsel for National Grid's network geothermal demonstration projects in Massachusetts. So some cross-state experience there. I think a lot of learnings to share. Jen Hendrick is a principal business program manager at Baltimore Gas and Electric. She's helping lead the development of a network geothermal pilot project there, which will get submitted to the Maryland PSC in July. Jen started in 2018 at BG&E and spent the first half of her career in electric operations focused on outage response and restoration. And the second half of her career so far is in strategy and regulatory affairs with a focus on innovative pilot designs, including implementing EV programs across the state. So with that, I'm going to go ahead and turn it over to Greg, and we're going to just baseline around what is everybody working on and just get an understanding of sort of where we are right.
Sure. Thanks, Tim. Okay. Quickly, I'm going to get very high level of the 3 projects that we're working on at Con Ed because there is another panel that I'll be on tomorrow. We'll have a deeper dive into those projects. So real quickly, the 3 projects that we have in design phase, and when we talk about design phase that we're in, we're about 1 to 2 months away from 100% CD drawings on all 3 of these projects. So we are very close to being fully designed, and we'll be submitting these projects over to the New York State Public Service Commission on July 9th, in which they'll make a determination of which of these 3 projects, 1, 2, or 3 of them, would be approved to go into construction. So the first project is it's in Mount Vernon, New York. It's city of Mount Vernon is just north of the Bronx in kind of southern Westchester. It's a pretty dense suburban area, I'd say. So you see here, our project consists of a district geothermal project. We're looking at distribution of bore fields right now. We're kind of down to 4 bore fields now in our project area. We're going to be connecting for the first phase about 42 buildings ranging from 1 to 4 family homes to some about 3 different churches, a medical center, office building, a fire station, the recreation center, and some multifamily residential buildings in the area. Pretty much the project will cover the installation of 12 to 14 inch 2-pipe system going through these series of blocks here, It's an HDPE system, and we'll be interconnecting those buildings. We'll be doing all the building retrofits, inclusive of all of the heat pumps that have to be installed in order to provide cooling, heating, and also domestic hot water needs for these customers. It's a pretty extensive project. We're about 200 plus boreholes right now that we're planning. We've done our test borehole, and we're looking forward to completing the design. Next project is different, no boreholes, but still thermal energy network. This project is in downtown Manhattan, near the Chelsea market in Chelsea part of Manhattan, and we'll be interconnecting the building you see on the left there, which is a large commercial office building which hosts a number of data centers. So they're a building that even in the coldest day of the winter is doing lots of cooling and just having that cold, that hot air from the coolant just be exhausted out to the roof of the buildings. We're going to be capturing that through a heat exchanger, putting it through our distribution system, which will be transferring it over to, you see there, those 3 buildings that you see highlighted are part of the Fulton Houses, New York City Housing Authority campus, public housing campus, and we'll be using that heat for domestic hot water for all 3 buildings. And then for one of those 3 buildings, we're going to be using our system for both heating and cooling. So the cooling of the building in the summertime will be offset by the domestic hot water use, and anything remaining will be sent back through to the commercial office building on the left because they have excess cooling capacity in the summer. So it's a pretty interesting project. Last project is in Rockefeller Center, pretty landmark area in New York City. Rockefeller Center, where the Christmas tree is, and the ice skating rink. That building at 30 Rock, it's interconnecting already. There's about 10 buildings interconnected, and they do a really great job of balancing and sharing heating and cooling throughout the buildings. But at the same time, in the wintertime, you can see the hot vapor coming off the roof of the building as they're doing a lot of cooling. So we're recapturing that, and we're supplying it to the lower 3 buildings you see there. And one of those buildings is pretty large, 71-story, large skyscraper that we're going to be coming off of district steam and going on to our system here with heat pumps. This is a heating-only project, and one of the unique things about this is the streets are so congested that during design we tried to go through the street, and it was so congested we're actually now going through the subway station. So we're going right through the MTA subway station with our distribution system, which is pretty innovative. Yep, that's it.
Good morning. So I'll quickly recap National Grid's projects in New York only. So the first one is down in Brooklyn with our gas-only utility, which we call KEDNY. We started with the anchor customer being NY-GEO, or New York City Housing Authority customer. It's 2 buildings, 7 levels, I believe, with also a community center, trying to leverage the fact that they obviously have an open space for the board field, but also seeing that there was a mall across the way that would provide for some balancing, and also a supermarket, which we knew was cooling dominant, which was kind of a primary participant that we needed to, who would be giving back heat as a cooling dominant participant in the system. So we started with that, and that's what we're working with, which is interconnecting the 3 NY-GEO buildings, and then the supermarket and a number of other retail stores in that mall space. And that's what we're currently designing for in that area. In Troy, we try to make each pilot be a little different. So this is also a board field project, but it's a little different in that we are going to only be building the distribution system and the energy center, and Troy LDC, Troy Land Development Corp., which is municipal arm, the development arm of Troy, the city of Troy, will be actually designing and constructing and maintaining and operating the bore field. And that's more to test out, what does that look like? How can you kind of apply what the current utility model is for both electric and gas, where we have a distribution company, and then we have separate resources or suppliers that are usually competitive. In this case, it's a municipality, so it wouldn't be a competitive type of entity, but would that in any way provide for like a good business model, lower costs in any way? I'm just trying to understand what the balance is of not owning the bore field, but also having some control over the maintenance and operation of that system. And in Syracuse, that pilot does not have a bore field. It's not a bore field pilot. It's using the wastewater treatment facility, Syracuse or County, Annadowa County wastewater treatment facility. So that will be our thermal resource. So that's looking at not a bore field, but how do we use waste heat, which this has a huge capacity for waste heat, and trying to interconnect. The other difference with this pilot is that it is connecting new construction for the most part. So, and also a lot of the new construction will be subject to the all-electric legislation. So they have to go electric, and trying to see what the benefit is of connecting with a thermal energy network versus potentially these buildings would have had to go air source. What does that do as far as like the grid upgrades or lessening grid upgrades that we required as this area is being developed?
Thanks, Bess. And then Jen's at a slightly different place in the process of developing a UTEN. So her presentation will be a little bit more about process, but go ahead, Jen.
Sure. Good morning, everyone. So we are definitely a different phase in Maryland. So to tell you a little bit about where we're at and why we're here, the Warmth Act was passed in Maryland in May of last year. And that said that gas utilities with over 75,000 customers are required to submit network geothermal pilot proposals. So those are due July 1st of this year, which is approaching much sooner than I would like to admit. And then we'll hopefully hear back from the commission by the end of this year. Some key Warmth Act provisions I want to highlight. It says that 80% of our participating customers have to be low to moderate income customers. It says the site must be served by gas today. So we'll be replacing the HVAC equipment with geothermal, and then for our residential customers, also electrifying all the appliances. So any gas appliances currently would be converted to electric. And then we have 1 year to construct the system. So once we get regulatory approval to go forward, we'd have 1 year to construct it. So that's the law that we are working under right now. So we've been in the site selection process basically since the law was passed. So we've been working with Tim and the CDM Smith team to find the best 1 to 2 locations that we will submit as proposals. So we started with 50 sites found by the CDM Smith team. And then we did a physical visit to about 40 of those sites. I think that was one of the most influential parts of our site selection process, bringing members of the CDM Smith team as well as lots of members from the BGE team to, look at site viability, the layout, what current equipment we could see was there. That helped us narrow it down to about 20 sites, which we could do an analysis on. And then we got to 5 that we did customer outreach. So that was a big part as well, as do we have the customer interest and buy-in at the 5 sites that we had selected. And now through that community engagement and an additional technical review, we have 2 sites that we're looking at proposing in July.
Great. So now we've sort of got our baseline set. Questions are really going to be from me. Now that we've sort of got our baseline set, I'm just going to go back to this slide around what everybody's working on. I wanted to dive into more of a cross-panel discussion, which I think will yield kind of the most value we can from everybody. So we've got 3 different perspectives here. And what I've found working with various utilities is that even when everyone's working under the same legislation, a company's philosophy and disposition toward how they want to unroll and act within that legislation varies. So, of course, Bess and Greg are working under the UTENJA law and that framework. We've talked a lot about UTENJA through NY-GEO and other conference events. But Jen's navigating the Warmth Act, and the Warmth Act has its own nuance, and it's got similarities to UTENJA, but it's also quite a bit different in some ways. So Jen, since you're in this site selection phase and working with your internal team to determine how are we going to approach the Warmth Act, can you share a little bit about what BG&E's philosophy has been to move a pilot forward, and how did you develop that internal approach?
Yeah, so we actually started before the Warmth Act even was passed. So in 2022, there was some Maryland legislation called the Climate Solution Now Act, and it mentioned geothermal in it. So we kind of had an idea that it was coming. So in 2023, we did a feasibility study to say, is geothermal even viable in our service territory, which is the central Maryland area, greater Baltimore area. So we did that feasibility study to kind of learn more and be prepared for what was coming down the line. We also, it was not me, but members of the BGE team visited our Massachusetts utility friends, and we learned from the Eversource Framingham pilot, just about what it would take to put together a pilot if that's where the direction went. So when the law passed in 2024, we were prepared and knew a little bit about geothermal before that passed. We, are in Maryland, have the regulatory challenges and have been used to responding to like building up a team in response to asks like this. So when the law passed, we immediately put together a team. We brought in some gas team members with the familiarity of like pipes in the ground and things like that, as well as our regulatory team, so that we had both our technical and like our strategic decision makers in the room. And then we, in parallel putting that team together, we jumped right into site selection. Again, knowing that from visiting our Massachusetts utility friends, we knew that we needed to jump into that right away with a limited time frame. So we went out to find someone that could help us with that, and that's how we found Tim and his team.
So I want to double click on that real quick, because I think you referenced sort of how influential the initial site visits were, and then you also referenced the composition of your team and the various subject matter experts that you guys populated that with. Maybe talk a little bit about the convergence of those and how that all worked together as it related to site identification, right? Because that could have been a process that was protracted, and I think that we got through it relatively efficiently.
Yeah, so we have, as part of our like PMO office, someone who's been in the gas organization for years, and so bringing him in and along on those site visits, he really can speak to what's in the ground, what the experiences that we've had in the area, and that's been super helpful to have him and the connection to that whole side of the business, where we've pulled on the SMEs to really, help us build out our process and know what to expect. And then also, like I said, having the experience, Jim, who's with us, knows behind the meter. So pulling on Jim's experience there to, understand our retrofit process and doing those site visits to see the site viability for those retrofits was really important to bring all those team members together to move it forward.
Yeah, I think it moved us all through that identification and down select process pretty quickly. Let's move on to project development, because that's certainly quite a gauntlet. Greg, what's been maybe the most unexpected challenge in just the project development process that you've experienced so far?
Sure, thanks, Tim. One of the things that's been a challenge for us, at least in the New York State, regulatory environment, is kind of the way that these projects kind of were staged out. It does make it somewhat challenging. So we were fortunate enough for pretty much most of the pilots that were proposed by the state to get approved to go into our next stage, which is stage 2, which is our design stage. But the way that's broken out, we're fully designing projects without, assurance that the projects could actually be approved for construction. And when you start really getting into the details of design and trying to ensure which customers are going to be part of your project without having that insurance to them, does make it challenging, right? So you're talking about a project, getting them some level of commitment without us being able to give that commitment back that we'll actually be building those projects. So I think that really impacted all parts of our project, from bringing on customers to how we're going to design it to how do we size it. We're sizing bore fields without knowing the total customers are going to be connected to those bore fields. So you really have to design things in certain ways. Some things are easy in the sense to say, yeah, make distribution means larger, because you can bring on more customers, and that's not that big of a deal to do. You may have to pay on more pumping power, but then we talk about installing bore fields. They're quite a premium, right? Our Mount Vernon project in Westchester, properties are premium there. There's a cost to that. There's a cost to those easements, and there's a cost to building them. So that's finding that balance has been something that's been kind of challenging. So again, fortunate we can design all the projects, but some restraint that makes it a little more tricky.
Yeah, it doesn't always allow both ends to meet when you want them to, right? Bess, what do you wish somebody had warned you about?
How much time do I have? I'll pick a couple of things, kind of following on Greg's, which is the customer enrollment portion. We found a couple of things. One is certain customers were very easy to enroll. Others took a little more time, especially commercial customers, when you're not sure who you need to contact to get that commitment. You may have a tenant, you may have a management company, and you have the ultimate property owner. So who's the right person? Who's the decision maker, depending on whether it's a big customer or smaller customer? Those were challenges that made some commercial customer enrollment a little challenging. The other aspect that I think, so kind of having that set up first, like trying to figure out, okay, who are these people, and really like trying to line up who the contacts are is really important, so you're not wasting time as you're doing your outreach. Another aspect is most people are actually pretty interested, especially usually you're offering them a turnkey type of operation or somewhat a turnkey type operation. In New York, you have Local Law 97, where they're looking at potentially, depending on how large they are, they're going to have to comply. Upstate, if you put all of New York, any kind of new construction is not going to be subject to the all-electric building law. So customer enrollment, people are kind of becoming aware. So customer actually getting people interested, once you get them interested, is good, but also trying to understand, okay, where are they? Because if it's new development, if you can't line up your construction schedules, well, they may fall off. So you really need to understand. And then with the regulatory framework we're dealing with, where it felt like in New York, at least, the timeline kept getting pushed out. That was an issue, whether it's new construction or if customers have renovations planned. You need to understand their schedule. And that's important to see, like, will that line up? Because you may lose customers if now your work will not line up with when they want to do the renovations, or even if they have a need to sell their property. And that happened in one of our mass pilots, where we had a maybe about a 6 and a 7 multifamily building. And then that customer decided, although he was very excited, dropping out because they ultimately decided they may be selling the property and didn't want to be somehow bound by the pilot and even though they were getting a turnkey service and getting everything upgraded and processed. So those are kind of like the things that we learned along the way. But if we had planned for them, maybe it would have taken less time, and maybe we wouldn't have lost certain customers along the way too.
I was going to try to make it easier on us with the mics, but it seems like that, there's all these spinning plates, so you sort of have to keep up in the air, and the ends you have to tie together, while also, maintaining compliance with the regulatory environment that exists for all these terrific reasons. So let's go into the regulatory environment just a little bit. Bess, we'll stay on you for a second. What aspects of the framework have, certainly there are opportunities created within this framework, right? A lot of opportunities, but there's also been some of the challenges you just described about trying to align to the timing of the implementation, the customer management aspect of this, and outreach aspect of this. Those challenges are significant. What else can you say about just having to kind of thread that needle through a pretty difficult eye?
All right, so unfortunately, there's so many challenges. Anybody who's doing this knows that, and try to come up with a solution for each one, right? That would work. And Greg mentioned some, which is not being able to give certainty and not knowing, will this ultimately be a business model that's adopted, having utilities provide the service? How do you enroll customers if you can't guarantee that you're going to be the person in 5 years or 10 years who's providing this service? So that framework, I think, exists both in Mass and New York. New York isn't 100% sure if they're going to ultimately adopt this utility scale model. Obviously, I think one of the regulatory issues is how does this play out? There's a longer time period for these projects because Jamie talked about regulatory lag for cost recovery, but there's also just regulatory lag for obtaining approval. So you're enrolling customers, you're designing, and then you have to sit and wait for approval. New York, at least when we submit in the summer, we'll have 100% design or be close to that 100% design. And we know that if we get approval, we'll be able to go out to bid. In Mass, it worked a little differently. You actually didn't even have a site selected. You just proposed a program and a potential budget without even knowing what the site looked like. So then the cost estimates came super low. So, and also was all the factors that came into play this last 5 years with inflation and supply chain issues and cost and labor costs really increasing. You base an estimate on something that happened in 2017 because we had a very small pilot in Long Island that when scaled actually ends up not being like a valid cost reference. So there's just a lot with the framework and that lag. I think if we do get to actually making this a business, then hopefully there won't be that lag and the issues with cost estimating and not being able to achieve the cost estimates that you now have presented to the PSC. So that's been a big issue.
Yeah, certainly managing costs with uncertainty, requires things like contingency, which can be a 4-letter word depending on the rooms you're in. Jen, with what you're hearing from the folks working in New York, how does that align or diverge from what's happening in Maryland? And how do you see, again, sort of the opportunity and constraints around that?
Yeah, so I think we align in terms of the regulatory lag for both Greg and Bess mentioned. We have been engaging our customers and gaining their interest in, December, January timeframe, but we may not know if we can go forward at all until the end of this year. So I think that definitely poses challenges that sounds like that you've had where are our customers going to continue to be interested, want to do this? Is there going to be change in ownership, things like that? So that's definitely somewhere where I think we'll align with your challenges. I think one of the things that we talked about in terms of diverging is maybe the phased approach, especially in New York. So for us, we're able to go through the site selection process and pick a site as it compares to Massachusetts. So we know the costs associated with that, but there are not the gates that there might be in New York. So we'll put together our full cost and proposal from engineering and design all the way through construction. So that will be an advantage if we get approval to go forward with the whole thing and won't have more, I guess, lag associated with it. But there's so much unknown right now. We know the sites, but we don't, there's a lot unknown with the costs. And so proposing that full cost definitely makes me nervous of how the things could change in the future. So I'd say that it's definitely a disadvantage.
Yeah, it's a challenge. I think it's a tough time in general to be a utility, right? On the one hand, there's a lot of friction about energy costs these days as though it's fully in their control. There's also a lot of pressure to decarbonize. There's also whatever history you have in your service territory. So Jen, I'm just going to stay on you once again and ask about managing trust with some of the uncertainty embedded in all of this. I mean, that's got to be really tricky, but could you just maybe explain how you think about that and how at BG&E you're trying to manage it and continue to engender trust, I'm sure.
Yeah. So, I mean, again, we're going out and proposing this thing that sounds great. So I'm a little nervous on trust in the sense of, if we get all this customer buy-in and people are really excited about it, and then we have to come back and say, oh, this didn't happen. That makes me nervous in terms of keeping customer trust And then I also think about, all the behind the meter work that we're going to have to do if we do get approval for it. That's a whole new space that we've never gone into. We're always outside the home, and in this project, going in, doing the retrofits, being responsible for that, both again for us geothermal, for residential, also doing the electrification, just going into that new world and how that can open doors to either build trust or, break down trust when we explore something new.
Yeah. Greg, I want to shift it over to you, and I'd like to hear Con Ed's perspective on approaching a set of demonstration projects, but focusing on how you're going to convey public benefit to the regulators with a series of large projects.
Yeah, I think when it comes to Con Ed, one of the things we always try to keep in mind and really is imperative that we do is the customer protections, right? So all the customers that will be connecting for these UTENs there are existing customers. There are electric customers, there are gas customers, there are steam customers. And we pride ourselves in Con Ed as being, one of the best utilities, in America and having a great reliability of service and having that trust with our customers. So when putting the customers first and having those kind of insurances that if they do come on to this voluntary program that doesn't necessarily have a set end date, right? It's a minimum 5-year pilot period, but there is nothing right now in the regulation that says anything beyond that 5 years. Is making sure that they're being protected, right? They're being protected, everything from a single-family home in Mount Vernon that, maybe signing up for this, and even though we're going to pick up the cost to those retrofits, and if anybody did major construction in your home, it's miserable, right? There's nobody has ever did major construction in their home and is not miserable. So, we're going to be putting ourselves through that process, right? So now we're with the customers, right? So making sure that not only is it a smooth transition when we have to retrofit, their homes or big buildings or historic buildings that we're going to be working inside of, very critical parts of their infrastructure. Then we have to make sure once they're on that they're not paying more for their energy costs than they were before they signed up. That's very important, right? That's no matter you're, Tishman Spire that owns Rockefeller Center, or you're, somebody that owns a single-family home in Mount Vernon, the first question is always, is it going to cost me more, and am I going to save money? And right now, even as we design them, the only way we can kind of build those assurances is by subsidizing these projects, right? And we talk about subsidizing it. We're really subsidizing it from all of our customers. So we're asking all of our electric customers, millions of customers, to help pay for these projects to get the learnings in place, but not only pay for the capital infrastructure of the project, but also to help us ensure that we can provide rates that doesn't have their energy costs go up. And that's a challenge, right? And that's something that we're working very hard on at Con Ed in different ways through our different projects, and we'll be proposing them in July to our regulators, and hopefully we can get approval to make sure that we're protecting our customers just as much as we're protecting our own investments.
Yeah. Well, I'll just leave that there. There's a lot there, but I think you guys have the right approach. And I think about, the more we electrify and when we're in cheap or affordable gas scenarios, customers are at risk of seeing their total energy bill go up if you put everything on the electric system, right? So there's a lot of dialogue as we move through the design phase and rate design about how do we avoid an instance like that, because that's certainly going to work against the mission overall of decarbonizing. You've already got this proposition to a homeowner once you're outside of a pilot phase to say, hey, go ahead and spend something like $50,000 on your home, and you'll probably save $50 a month. No one's really signing up for that, right? So I think that part needs to really be thought through while thinking about rate structure, dual rate structure, and how do you avoid saddling people with costs that shouldn't be necessarily be theirs. So not an enviable task whatsoever. Let's move out of talking about sort of those customer aspects and talk a little bit more about design. And I think I want to start with test bores because it feels like there's always a story about test bores and drilling, especially for folks who don't do it every day. So I know when we drilled the test bore at Framingham, one of the brief stories I have is everything went great. It was a terrific test bore. The TC came back in a positive way, better than what we had originally modeled. But then when we went to check the hole, when we were approaching construction, it was about 90 feet out in the center of the right-of-way. actually on the other side of the street, because at about 150 feet, the drill string had bounced off of a boulder and just kept going in that direction. So these sorts of things happen, but now we're a utility, and there's liabilities associated and property rights to be concerned about, and it's not just doing it at my house. So I've said probably more than the moderator should there, but Greg, why don't you talk a little bit? I know you guys had a great test hole done, but even with that, it's not without its challenges. So why don't you tell us a little bit about that?
Yeah, I think this is something that was one of the biggest shockers. I mean, I've been in different parts of the utility space at Con Ed for 20 years, and we pretty much know where we put things. I mean, it sounds simple, but like there's nothing that we install that we don't, maybe when you're shooting a bullet for gas service, you may not be 100% sure exactly, but you're still pretty close. When we learned about geothermal boreholes and really the verticality of them, where do they actually go? It's not, in the private side, it's not all that important. If you have a big campus and you have big space and, I think I hear like things like, 1 in 10 collide, that's good. And I'm like, that's crazy, right? As a utility, that's just like sounds ridiculous. And I'm just being honest. That's kind of the reaction. It's like saying it doesn't make any sense, right? So, when we did our test borehole, we went out and we kind of surveyed and put out, some requests for some quotes from different drillers. We asked them all, can you ensure verticality? And nobody did. Nobody would commit to we'll be within this much. And that was kind of telling for us. Now, we did go with a driller that did a really good job. We went down 850 feet, and I think the first 600 feet were within a foot, which is great. So if we did a 500-foot test borehole, I probably would be here saying, this is great, they got it, right? But in the last 100, 200, 150 feet, went off about 30, 40 feet because it probably hit something down pretty far and it detoured. Luckily for us, it stayed within the same property we were doing the test borehole, but that's not always the case, right? We're in tight quarters in a lot of these areas, and it matters where they go. So I think that's an area that if it's going to expand for utilities, that I think that technology that's using the oil and gas drilling needs to kind of merge into this so we know where these boreholes are going. So they're staying on the properties that we're putting them in.
So Jen, we have not done any test bores yet at any of your sites, but what questions do you have for either Greg or Bess about test bore process and drilling?
Yeah, I guess what's on our mind right now is, if you had your choice, when would you do a test bore in the process? Because that has been up for debate recently. And then, once you decide to do it, how long does it take? Because, we're right now having a conversation, July 1st. Do we try and do it right now at the last minute? Should we wait? Those kind of things. So I'd just be interested to hear.
I'll go first, but can I do a phone a friend? Melissa, she's our engineer on our projects, and so I'm not going to play engineer. Do you have a preference for when we would do a test bore? I know we've done it in different times. Yeah.
Melissa Morrow, everyone from National Grid.
Hi, everyone. Sorry, wasn't expecting to talk. So the question was when in the process we would ideally do a test bore. I think. So I think we did a test bore with our NY-GEO project, and we did it, after kind of figuring out where we wanted our customers to be, where our bore field was going to be, and after talking with the NY-GEO residents and the people in the area. So I think at a point where what customers you're targeting, what buildings you're targeting, and kind of getting it, getting the appropriate people involved in that process to that way gain the data that you need in order to know whether, this is a good spot for your bore field, if this is, if you're going to need more room, less room, that kind of stuff. So I think earlier on is probably more ideal, but just involved enough to know when, that you have the right group of buildings that you want to tackle. Sorry.
Yeah, and just to add to that, it's when do you know exactly where your bore field is going to be, right? So for our Mount Vernon project, we always had one bore field set on one piece of land, owned by the city, that was going to be the place. And we were going into design. This project was about, a year and a half old. we drilled the test borehole, right? And then the city has come back to us and said, oh, hey, by the way, this other entity is going to build a building, or where you want to put this, right? In the same piece of property, right? So, luckily for us, there's a basketball court owned by the city across the street. So we're going to go across the street, but like our actual test borehole is not going to be probably part of our design in the end. So, knowing where you're going to be is a great time to do it. You could have some of the design start with some conservative figures. We originally designed it a bit more conservative. Our test borehole ended up being, had a better rating than we originally designed for, which is good. But that's a key thing. For us, also a test borehole, it was more than just a test borehole for the sea conductivity of the ground. For us, it was really about this. That was the first showcase to the city of Mount Vernon of what this project was. And so it was important for us to really take that to a next level and be the nicest, cleanest type of setup that we could have for a test borehole. I mean, I've been to some, when I first started coming to these a couple of years ago, and got excited to see any drill line I could see, and I saw some that looked like, I don't know, a mud pit, and I saw some that were more clean, right? And I said, well, if I did this mud one that makes a mess in front of the city of Mount Vernon, they're going to kick us out of the neighborhood, and we're not going to have a project. So we did that test borehole, and I had drillers come up to us and say, this is the cleanest test borehole we've ever seen in our lives. I mean, we had vac trucks, all the water, and right to trucks. It was fenced off. They used pads for the tracks for the driller. You couldn't even tell we were done, other than something the size of that picture sticking out of that one test borehole. So it costs more, sure, but those are some of the things to consider, because not just the test borehole in front of the ground, it's actually that you're testing out the project in that community, that neighborhood, and that experience is very important. It was a good experience, therefore our project continues, right? If it was a bad experience, we probably would not have that Mount Vernon project up there.
Yeah, so a lot of insights there. And I also think that time is a factor, right? Like, how much time do you, what are you going to use the TC test for initially? How important is it to get, early stages for design? Because as a designer, the more data we have out of the gate, the faster we can go through the process, right? So I think there's a lot of factors that play into exactly when you want to do this, with the general premise being earlier is better, but you got to have a few things pinned down first, right? All right, so I want to leave a little bit of time for the audience to also be able to ask folks questions here, but I would be remiss if I didn't get into the elephant in the room generally, which is CapEx, right? So I think the barbs that get thrown toward geothermal tend to be around, gosh, it's just so expensive out of the gate. And the bad fact is that it is pretty expensive out of the gate, because generally, unless you have a thermal resource available to you, like Greg has, like Bess has on a few of her projects, you're going with bores, and that's an add-on cost from what would otherwise be for the mechanical system, and there's just no getting around that. So current project economics are challenging, and it's only going to get worse as pilot phases wind down, and we have to think about, burdening homeowners and, what incentives are going to be available for them there. But Bess, I'm going to go ahead and start with you. Your background spans legal and engineering perspectives. How do you view the adequacy of the current rate structure to support a transition? And if you were untethered by the current regulatory environment, could come up with anything, what sort of thoughts do you have about, I know that's a big question, but what kind of thoughts do you have about the rate structure today versus what might be necessary?
Right. So the current rate, is this working? No. Oh, now it's working. Hello? Okay. The current rate structure allows us to, once approved and we have a cost, we're going to recover from either our gas downstate or hopefully our gas and electric customers. So it's a thermal energy customers, but we're recovering. And then we're also trying to come up with a rate or a fee that they can pay that would offset the cost that our gas and electric customers will be carrying. So that's kind of the current rate structure of how we're going to recover, which is not how ultimately our utility will recover, right? Like ultimately, the customers that are being served by the thermal energy network are the ones that are funding all the projects. So eventually, if there's a thermal energy business, then you would want the rates that you're collecting from your customers to then be able to pay for the thermal energy network. So how are you going to do that? Because obviously networks are served by electricity, so they're going to see an increase in their bills and their electric bills. And then you also have to charge a thermal energy charge above that. And we don't yet know how we're going to charge for that. And that's what these pilots are designed to do. So I can't say I have an answer to your very last question because we need to see, okay, how does the usage come into play? And what if somebody's cooling dominant and they're actually benefiting the system? Do they get a credit? So there could be credits for trying to get cooling dominant customers possibly to try to balance the system and lower costs. That's one way to handle that. But then what about the customers that are not cooling dominant and they're seeing an increase in electric bills, and also now they may also have a thermal energy charge? I have to stop. Sorry.
Well, I will say, I think we've got like an incredible amount of just folks, like a tremendous amount of experience going through the process for the first time. Let's remember, utilities haven't done like a service expansion in like 20, 30 years, probably, if not longer for some. So this is really, there's been a lot of learnings through the tender process just through design, and we talked a little bit about that. But the last thing I want to ask, and then we will leave a few minutes for questions, is, and anybody jump in, but let's look into the crystal ball. Regardless of whether all your projects approved, some projects aren't, what have you, where are we 5 to 10 years down the road as it relates to TENs and utilities?
I mean, I'll start there. I think the most likely place that these will be able to remain at the utility side is for us to be able to look more long-term planning on where these projects should be. I think these projects are great tools in the toolkit that we'll have for electrifying and decarbonizing our buildings and our service territories. And I think, but we need to really be able to be working with our municipalities, with our cities, with developers, to be able to in the planning process, or as they're putting in new water mains and sewers for new developments, to be putting in thermal network pipes as well, and then being part of that planning process and then being part of the zoning process. I think that's where you're going to get the best benefit out of them. These kind of one-off, standoff pilots, they're very expensive, and you don't have the customer base to support the cost for them. So that's where I think we're going to, potentially see these kind of grow in that space.
Yep.
Greg stole my answer.
Greg, I just blanked. I didn't even hear your answer. So, isn't that awful? So I don't know if you said this already. And is this the future? In the future, I'm hoping that we're going to be looking for all thermal resource options, because I do feel like moving away from, bore fields will be a part of it, but also looking for all, like you're looking at a data center, we're looking at wastewater treatment facilities, which we have discussed how a lot of them aren't necessarily near buildings. They're kind of like on the outskirts. But just trying to look for other thermal resources that will lower the cost because of bore fields. I think that will be like kind of something that we really need to do in the future. And then also quantifying, and I don't know if you said this in your answer, quantifying what is the benefit to the electric grid, because that's ultimately, these pilots hopefully will provide some of those answers so we can start doing like the benefit cost analysis for everything, which is, okay, this is costing this much, but look at how much we're saving on the electric grid. So that would maybe make it look more affordable. But I'm a huge proponent of thermal energy networks, and I really do hope that we can, with everything we're doing, that we can bring costs down and make them available to more people as well.
Well, thank you all for indulging me in the last couple of questions, and we can go ahead and open things up. There's a mic socializing, so why don't you just go ahead and pick them up?
I'm going to pass them out. All right, so just tell us your name.
Good morning. My name is Chase from Ramble. My question is mainly for Greg. So in the Con Ed STEAM decarbonization report your team published late last year, geothermal looping, or deep geothermal more specifically, ranked quite low in your technology assessment criteria that you had. I think it, in fact, rated the lowest amongst technologies, that didn't have some sort of fatal flaw, like maturity or something like that. Do you see that assessment changing all that much as your pilot programs come to life, or as the regulatory landscape changes at all?
I don't think, good question. I don't think they're necessarily tied, because we're going down 850 feet for geothermal. The deep well for heat, I think a lot had to do with the geology of the area where that our plants are, and it just wasn't a great fit when they did those studies to see where they were. So to get heat out of the ground is different than what we're doing on these pilots. So I don't think they're connected.
Hello, this is Seth Berkman with NY-GEO. Thank you guys for your presentation. I had a quick question about planning for expansion or designing for expansion. You guys spent much of your presentation talking about the physical planning for the various systems. I do not know a lot about geothermal, so I apologize if this is ignorant, but it seems to me that with network systems, they become more efficient both physically and economically when more customers are added to the system. So as you guys are going through your design process, are you designing for the potential for future expansion? And can you just speak a little bit about how you think about that? Thank you.
I mean, I'll go quickly on like, for instance, our Chelsea project. We're connecting one data center with some housing. That area has a lot of data center that has a Google headquarters. So we're putting T's and valves in place ready to connect future customers when they come, right? We want to limit redigging the streets up. That's expensive. We're oversizing the mains of our Mount Vernon project. We're allowing for our energy center buildings to have more capacity to put additional pumps in for future uses. So those are some of the ways you do it, but to find balance, because the cost of these projects may be cause these projects not to get approved. So you got to kind of really thread the needle between being ready for expansion, but also not overcosting the projects where our regulators won't approve them.
So that is actually one thing that we will have to answer in our pilot proposal. So the commission has outlined that they want to know what we're thinking about for expansion. And at least one of our locations that we are looking at right now to propose is the end of a gas line. So as we were to expand it, there's a lot of buildings and residential in that area where we could expand to. And if we're able to expand, then we could take the end of that gas service out of service.
And expansion is definitely something that we're also working into. Our three pilots, Syracuse has natural expansion capabilities because thermal resource has so much waste heat. So we still are designing the distribution system, right? The distribution will be larger so that we could connect new customers. And those costs will come down because it will just be maybe like a quick lateral or something, a quick connection. So that would start making this project really, as things are built up in that area. So that already has a great potential for expansion. In Kedney, we also have potential for expansion because we're not necessarily connecting every possible commercial customer. If there's like more cooling dominance, there's also it's like the subway effluent area that could be used as a thermal resource. I mean, there are definitely ways of expanding the system and connecting more customers. So Kedney also has a potential. And Troy, we're just going to have to wait and see because right now it's a bore field. It depends on how many connect initially, what that capacity is, what it looks like in operation. We're modeling and we're thinking this is how many can be connected, but we don't know if operation actually could account for more. There's the river right there. I don't know if that would be potential for expansion as well as a thermal resource. So, and Melissa, are we also designing Troy with a larger distribution loop or just with, I don't know if we're doing that in Troy. What? Yeah. So what we're trying to definitely allow for expansion on all of them because they're pilots, but it would be great to then go to the next step.
Yeah, that's actually been something I think about is the pilot's one thing, but you're essentially laying out your largest CapEx initially with any of these systems because everything should be incremental from there, right? Once we have a good sense for how that series of bore fields is performing and how the loop's performing, then you can really start to say like, okay, what do we actually need to bring on a few more customers? Do we need more bores? Do we need more pumping? Because maybe not. And certainly we all hope to learn more about the Framingham expansion loop. I think if Brian Erlab's in the room, he's been working with heat on an expansion. So hopefully that'll go out to bid and we'll see, dramatically reduced costs for approximately the same amount of connected customers as was in the original loop.
Can you hear me? Yes, you can. My question is for Bess. The Vandalia Street project or avenue, that is pretty close to a wastewater treatment plant, and I'm wondering if you are considering adding that to the mix. And then secondly, have you considered putting in a shark or other in-building wastewater treatment system? And thirdly, how does that NY-GEO facility's future look in relation to the air source heat pumps that NY-GEO is putting in many of its buildings? Thank you.
I'll just take the last question, which is we will be doing an LCA I don't think we've done those calculations 100% yet, but we would be comparing as part of our filing what it would look like if we had done air source versus what we're doing now. So we would have that answer. We don't necessarily have it right now. I know we're doing shark, so I'm going to give it off over to Tim, who's our consultant, and he can definitely answer because those are all great questions.
Yeah, we'll work bottom up. So Bess handled the last one. There is a shark system. So it's a building level collection system that we'll use from the NY-GEO towers. And effectively the way that site is sort of working now is between the shark system and the refrigeration load from the grocer that's over across the street, the boreholes really act as a balancing mechanism, right, with those two thermal resources on it. So we don't actually need more thermal capacity for that system. In fact, we've got a little too much. We did look at the wastewater plant that's down around the way. The challenge with that one, and we looked at whether or not we could site something immediately in the vicinity of that wastewater plant. It's a little too far away to be able to bring all that horizontal piping over to the NY-GEO towers themselves. So we look at that horizontal piping cost, even though it's got thermal energy storage capacity, it's also a parasitic cost on the projects. We want to limit pipe runs where we don't have customers connected to the maximum extent possible.
But potentially future for expansion, maybe.
Yeah, if we moved in that direction, it would be a great way to balance out things and connect a whole bunch of customers to, I think, the east.
Go ahead. Okay. Sorry if that's creating any feedback. John Thomas with Water Furnace. I got a two-part question, if I could. Thanks for the discussion and the panel. It's very interesting to listen where you're all at on different projects and different part of the journey, so to speak. So I'll just address it to the whole group. From a cost standpoint, some of the pilots that we've seen, and we all understand that pilots are for learning, and they're a bit experimental, more experimental than we would like sometimes. The costs, if you look at it on a cost per connected ton basis, is interesting, and they're high. And so from an industry perspective. And so my question is, for those that have gas utility experience, are you comparing the distribution installation costs of the energy network? We understand the bore field, where it's located, but the distribution piping and the laterals to connect to homes, are you comparing that to your gas infrastructure costs? As they should be pretty parallel, I would think. And if they're similar, then that would be insightful for all of us to understand.
100 answer.
Yes, they're similar, but it will be as if you're bringing gas into a whole new neighborhood, right? And you have to add in a SCADA system to communicate, metering, controls, billing that hasn't been done yet for thermal networks. Like, there's a lot of other costs that go to these pilots outside of design and building we have. So when you add in creating new billing, new tariff, new rates, all new bills, customer service training, there's so many other parts to utility getting into this business that get added on to the cost of these pilots because they actually have to happen because they're functioning as a utility. When you put those together, yeah, the cost of these pilots go kind of high, right? And those are going to be more upfront for pilots than they would be for regular business.
And also, when you think about building out the system first, obviously costs more. As far as your question about comparing, I know in Massachusetts, we compared with our Lowell project. That piping had to go a little deeper, and it was estimated there might be some ledge. So those costs ended up being a little higher than our regular gas distribution costs. But so that was, we definitely did a head-to-head comparison, and it just ended up being a little higher, but it really wasn't that much higher than what we would have seen with our gas. It's just because at least in Lowell had to go deeper. I don't know if they all always have to go deeper.
Yeah, not always, but it's not infrequent, right? Because there's concern about ground freeze and obviously the glycol helps, but then you're also avoiding just the installation around other utilities.
Yep. So I know we're short on time. So second quick follow-up. Are any of the groups, any of the utilities looking at using the actual road right-of-way to actually put the bore field right down the middle of the street as opposed to a remote location where pumping watts and moving water is not negligible?
Super quick, when you do that, and depending on your municipality or city, like City of New York, the way it works is we have a franchise to put our equipment in the street, but the city reserves the right to tell us we have to move out of the way whenever they want to do anything. So putting bore fields in this right away, it would be, very hazardous, right? Because they can just say, we got to do a new water main, you have to move, and they could order us out of the way. So that's why distribution piping is one thing. Bore fields, you really can't move them, right? You can move a main, but you can't move a bore field. So that's one of the big reasons why that's not great, depending on where you are.
One of the things we also learned on a project in Mass that did have right-of-way bores was just the nightly demo to make room for emergency vehicles. So regardless of where you are, there's just another setup time in the morning that you wouldn't have in a centralized bore field. So you just wind up with a production rate that's going to be at a quarter to a half a bore a day, which is, hurts the economics. So folks, I think we're completely out of time. Thank you all for hanging in there with us. Let's give this panel a round of a hand. I thought they were terrific.